There we go. All right. Okay, common factoring. So when we talk about factors, we're talking about numbers that multiply together to give us a desired number. Like the factors of 21 are going to be 1 and 21 and 3 and 7. Does that make sense to everybody? So it's all about multiplying. So like this one, we're looking for 28 and two numbers that could multiply to give us 28. Is there another factor set that would work to give us 28? What would give us 28?
2 times 14.
2 times 14. Is there another one? 1 times 28. So sometimes you don't have one particular set, you'll have many. And when we're going to do our factoring, you're going to have to get pretty proficient. You're going to have to get really good at knowing your factors. What numbers multiply together to give each other desired numbers, okay? So you know those little multiplication charts that you had in elementary school, like the 10 by 10s, and like you had what they multiplied to get to 100, and you had those all on one sheet? Those are super handy, and if you have one, if you're not 100% sure, instead of always going to your calculator, that table might be helpful to you too. Okay, so we're going to do it with letters as well. So you guys probably would have done factors in grade 9? Maybe? Sort of? Like factor trees? Have you ever done a factor tree? No? Okay, so a factor tree just looks like this. So what are two factors of 21?
3 and 7?
Oh, this is a bad one to do. Let's do 24. See, I fixed that really easily with that. 24.
7 times 4?
Nope.
6, 4.
Brilliant. Okay. So, ooh. 6 and 4. We're going to start there. Can we do factors of 6? What are the factors of 6?
3 and 2?
3 and 2. Okay. What are the factors of 4? 2 and 2. So what you've done here is you've reduced your desired number, your 24, down to prime factors. We call them prime factors because guess what kind of numbers they are? They're prime numbers. Okay, that's just like, sometimes I go on a tangent to talk about numbers because I really like this sort of stuff. Okay, so we're going to do this again using algebra today. So we're going to be looking at things that are common between them. And then if you choose to come to grade 11 pre-cal, we're going to do this with letters and numbers under a root sign. It's going to be super fun. And we're going to do a little bit of the root sign stuff this year as well. Okay, so you're looking for the greatest common factor. So the GCF, if you don't know what that means, that is greatest common factor. Just in case you're not sure what this, we do all kinds of weird abbreviations in math, so if you're not sure, just ask between all the terms in the original polynomial. So we're going to do this with algebra today. Look for a common number that can be divided out of all the coefficients and the largest power that is common to all terms. Place the GCF outside the brackets and then whatever's left inside the brackets. Okay. That's a lot of words, and it doesn't make much sense, but we're going to work this out. There's a couple of ways to do it. Some of you will be able to see it. Those of you with really solid number sense will be able to see it leap off the page at you. I've been doing this for a long time, so it leaps off the page at me. But as we learn, we might need some different approaches. So I'm going to show you a couple different ways. I'm going to take the factors of 6. Just give me one set of factors of 6.
3 and 2?
Perfect. So I can write this as 2 times 3 times c. You guys would agree with me? Is that the same as this term? 2 times 3 times c. If you multiplied all that together, you get 6c. All right? All right, now we have a plus sign. And we're going to do the factors of 9. Just give me one set.
3 and 3?
3 and 3. You guys are picking good ones. So 3 and 3. All right, now I'm going to get my I need to get some more highlighter colors. So this is a term, and this is a term. So this is a binomial. It has two terms in it. So it's a binomial. Okay. So what factor, remember factors about multiplying, what factor do those two terms share? 3. Grabbing a different color. So there's a 3, and there's a 3. Now I know there's 2 3s here, but you're looking for the number or the letter that they share. And this only has 1 3 in it, so we only have 1 3 here. So what if we took that 3 out? So that's the greatest common factor. We're plucking that greatest common factor. So that's the GCF here and here. And we're going to pluck it out, and we're going to put it in front of the bracket. Okay, so we're like picking it up. We're putting that 3 out there. And because it's shared, we only have to write it once. It's common. That's why it's called a common factor. It's common in both places, so we only have to write it once. What's left behind? What's left behind?
2C times 2C plus 3?
Yep. So does that make sense to everybody? What you just did was you common factored there. And I'm going to say that a lot to you. I'm going to say, did you common factor? Did you try common factoring? So that's something that we always try to do right away. Now, to check to see if I got it right, like if I had this on a quiz, multiply it back through. Do the leapfrog, the distributive property, back through it. So we have to multiply by this term, and we have to multiply by this term. So that was what we practiced yesterday. So 3 times 2c is going to give me 6c, and then 3 times a positive 3 is going to give me a positive 9. This matches that, so I know I've done it correctly. Does that make sense to everybody? You don't have to check them, and especially like easy stuff like this one where you can kind of see the multiplying it works. That's awesome. Now, if you had picked a different set of factors for 9, let's say you had picked 9 and 1, that's not going to show you the one that you're going to pull out. So you kind of have to think about the two numbers, think about their relationship together. Okay, let's move to the next one. And some people will go right from here to here because they can see it. But if we need the helping step, this would be it. Does that make sense to everybody? So it's all about like picking what we need. So what are the factors of 6c? Did we not just do this one? We just did this one. So 2 times 3 times c. All right, let's talk about 4. What are the factors of 4?
2 times 2.
Brilliant. 2 times 2. And let's talk about c squared. How many c's are multiplied together to get c squared? 2. So c squared can be written as c times c. Remember, those are our exponents. Those are our repeated multiplication. It tells us, the exponent tells us how many c's are multiplied together. So if that was a 5, how many c's would I have? 5, right? If it was 10, I'd have 10 c's. So, all right, here we go. So first term, second term. What's common?
C and 2.
Yep, they both have a 2, and they both have a c. So those two things are common, so I'm going to pluck them out. Those are my greatest common factors, so I'm going to pluck those out. They go out front, 2c. I only have to write them once because they're shared. And what's left? What's left? We have a 3 plus 2c. And if I want to check that, I'm going to multiply that 2c back into the binomial. So 2c times 3 is 6c. 2c times 2c is 4c squared. Do you need to check it every time? No. but I want you to be confident in your math. If I were to do this on a quiz, I might do a check just to make sure I'm going to get 100% on that question. Right? Okay, common factoring. Do you guys like this spread out part? Like, do you like listing the factors? This will come in handy when we do radicals. Like, so if we practice it now, it will come in handy when we start dealing with root signs. FYI, root signs, the fancy word for them in math is radical. Okay, because nothing is ever simple.
Miss John, I have a good question.
Sure.
Is it possible to get different answers?
No. All right. Okay, so let's look at this one. Right away, what do you guys notice about the numbers? Like, just look at the coefficients. What are they? They're all multiples of 5, right? 5, 10, 5. They're all multiples of 5. So what's the common, like, what's the number that we're going to pull out? 5, right? It's the common factor for them. So I don't have to worry about factoring this one. 5 is a prime number, so what are my factors? 1 and 5, right? If it's prime, it's only 1 in itself. So I know that that one's 5. 10, can 10 be written as a factor that has 5 in it? Yeah, that's going to be 2 and 5. So you're going to get way more comfortable with numbers and factors. And the more comfortable you are with like pulling things apart and looking at them, the faster this will go for you. And then we're just going to have 5. Now, did I need to write times 1 here? No, because it's just going to be itself, right?
Yeah.
Actually, you know what? Let's keep it consistent. Let's keep it consistent. And then Z, how many Zs do I have? 2. Remember, it's the repeated multiplication of exponents. So if this says 2, that means I have 2 Zs. All right. So, looking at all this, what's common?
I.
Any letters?
The Z is common in 2 places, but not all.
Right. That's perfect. So Z is Z is common here and here, but if it's not common in all 3, you can't pull it out. So the one that I'm going to pull out is 5. All right, so I pluck that out, and I only write it once because it's common in all of them. What's left here?
1.
The 1. So that's important because it needs to be there. It needs to have a place value. Some people just pull the 5 out and just kind of pretend that that term doesn't exist, and that's going to be bad, oh bad. 2Z minus, now do I need to have the coefficient of 1? I don't, but if you want to put it there so you feel more comfortable, that's fine. This is going to be 1Z squared. Now, if I had only pulled the 5s out, I'm just going to rewrite this question. You guys don't have to write this down. I just want to show you a common mistake that happens. So this is just like extra. This is a common mistake. So what happens is we see that the 5 is common. And then what people do is they forget that there has to be a place there. So if we took out the 5 in all of these, they say, oh, what's left is 2Z minus Z squared. Now, the reason why I would know this is wrong, so that's incorrect. Like, that's a mistake. Because if I go back and multiply it through, this is going to give me negative 10Z minus 5Z squared. Does that match the original? No, it doesn't. I'm missing that 5, right? So that 1 is really important that it stays there. So that's a common mistake. So that's why it's kind of important to put that one there. Although it doesn't feel like reasonable to put it, it's good because it reminds you that it's got to have a placeholder. Because if I multiply this through, if I multiply that through, now when I leapfrog here, I get the 5. And then I get the negative 10z, and then I get the minus 5z squared. So that is the same as the original. So this is bad. This is bad. Bad. Bad, oh bad. Don't do that. All right. So if we want to verify that the factors are correct, how I did it here, multiplying it back through, that is a verifying that we are correct. So let's do this one. Do you guys want to try it first?
Yes.
Okay, you guys give it a shot. I'm going to pause the screen because I'm going to write all my factors out while you guys are writing out your factors. So give it a shot. So think about those numbers. What numbers do 12, 20, and 16 have in common? What number divides evenly into all of them? Oh, I think we need more room. Yep, to the back bin. See your D block? The slot under your D block sign. Can I show you guys my factors? And see if you guys have your factors? I just moved to the bottom of the page just because I didn't have much room. Did you guys expand your factors that way? Where'd you put the negative sign? I put mine on the 4, but does that make sense? You could put it on the 3. Did you put it on the 3? Did you put it on the 4? Did you keep it consistent? I love it. Those are all the questions. I'm freezing again. All right, keep going. All right, how we doing? You good? Sort of, kind of. This one was a little bit confusing. So if your answer doesn't look exactly like mine, you probably did it really, really well. But we got to tweak it a little bit. And I did something very different. So I went through, and the thing that I saw common in mine, because I put my negatives all on my 4s. Because you guys know that a positive 4 and a negative 4 are different numbers, right? So it's not common if they're not the same. So I made a decision that I was going to put my negative number on my 4s. If you did positive 4s, you are 100% correct. So I'll show you what this looks like with positive 4s after I'm done this one. So also an X was common, and so I spread my X's out. 1, 2, 3, 4, 5. So I spread them all out, but 1X was common. There was only 1X that was common because of this term. And then my Y, a single Y was common. So I pulled out my negative 4XY, and that left me with 3. And how many X's? There's 4, so that is an exponent of 4. And then, okay, so this is where it got complicated, because I pulled that subtraction sign with me. I pulled it out. But if I take a negative 4, what kind of 5 is left? What kind of 5 is left? The positive 5, right? So that's why that became an add sign. I'm going to show it to you if you took a positive 4 out, what it looks like after this. So if you took a positive 4, it looks a little bit different. And then here, again, I took that negative 4 out, but it left me with a positive 4, so that became an add sign. Okay? I'm going to multiply them all back through to see if it works. So that's going to be negative 12 x5y, negative 20 xy squared, not plus, minus 16 x squared y squared. And I do believe that was my original equation. So this is my verify. So what I just did here by leapfrogging it back in, that's my verify or my check to see if I did it correctly. I'm going to do it with a positive 4 now. So if you're somebody who's sitting there with a positive 4, I'm going to do that for you right now. Can I do it up here? I can do it up here. Okay, so we had negative 12x exponent 5y minus 20 xy squared minus 16x squared y squared. Okay, so if I took a positive 4, negative 3x times x times x times x times y minus positive 4, positive 3, because I have this, I'm leaving it as a subtract sign there. X times y, leave my subtract sign, 4 times x times y, getting a little sloppy. So you guys agree this time that what do you need, Rahat?
Like, see, 4 times 3 equals to 12, not 20.
Oh, sorry. Good pull. Okay, so if I'm pulling the positive 4s this time, and I'm going to pull a single x, and I'm going to pull a single y. It doesn't really matter which y I pull, but I do need to pull one y or one x from everywhere. So this time I'm going to pull out a 4xy. So the difference is my last time I pulled out a negative 4xy. And so I'm left with negative 3 x to the exponent 4. This time I have subtract 5y. Subtract 4xy. This is a totally 100% correct answer. It's different than the one I gave. So if it's a positive negative thing, there are different answers. Because when I verify this, I'm going to get the exact same answer or the exact same as what I started with, which is great. It's just that positive negative thing. So they give us the same result. They are both 100% correct. I would mark you 100% correct if you did it my way or if you did it this way. Does that make sense to everybody? Sorta, kinda? That's the great thing about math. If you tell your story correctly, sometimes we take different paths to get to the same place, which is awesome. Okay, so that is today's lesson on common